Welcome. So today we're going to take a look at lighting systems. Before going into the content proper, right, let's take a look at some images. So this is an image of an interior design, a quite pristine and very minimalist palette. And notice that actually the designer has a very specific way of playing around with material and geometry, right? Not so much playing around material, but more like geometry. And because this topic, we are looking at lights, right? So take a look at this image, right? And then you think about the kind of lighting that is used in this composition and how does it support the design intent that the designer has in mind in composing this kind of imagery. Okay, so next image. Yep, so for this, I would say at first glance, most of the attention is on the ceiling. It has is very lit, is well lit, uniformly, interesting geometry, and notice that because of the way the ceiling is curved, right, it captures and it deflects the light in a very soft and gentle way, right? So this is an example of how actually daylight can be captured and dispersed to create this kind of lighting effect. And it's also interesting to consider how the natural daylight can coexist and come together with artificial light, because daylight is only available in the daytime, right? So what's going to happen at nighttime? How the two balances each other out, helps each other to achieve this uniform and functional lighting and qualitative lighting throughout the day as and when the user needs it, right? And then the next question is, of course, how do we then detail and conceal the artificial lighting? Okay, that is why to understand how the system works is important. And then if you look further down, you can see a strip of LED light that's integrated with the carpentry, right? The shelves overlooking the workstation. So even if we have a very well lit uniform roof plane, okay, we still need to consider at a functional level the functional lights that are around the workstations, right? Because if you specify a light that's hanging at 3 meters, right, it's very different from the task lighting, the lamps on the desktop that we turn on for us to read our books. Okay, so many different layers of thinking we have to go through when we are designing for lighting for the place, for the specific space. Right, so this is another image, very nice, earthly color palette, material palette, pitch roof, exposed rafter, and underside of the ceiling. Okay, so in this kind of setup, in this kind of material palette, in this kind of context, right, what kind of light is important? Probably natural daylight is very important for the composition. And in this image itself, you can see, because it's very geometrical, it's very controlled, right? You have pendant lights dangling from the ceiling, and how it sits very nicely proportioned with the exposed conduit, right? They are carrying the electrical cables and as well as functioning as supports for whatever art that the owner would like to feature. Okay, so the point is natural lights, artificial lights, those are parts of the equation or very important components of the overall composition. In fact, when you are conceiving and you are imagining the space as a designer. Okay, so I think the previous images, most of them are very well lit, right? But what if you are after a space, especially in hospitality design, right? How can you use light to bring out the characteristics of the material, right? And in this case, if you have marble, very nice texture, how do we bring it out? Marble is not opaque, it's translucent, right? So if you cast light through it, you can really elevate the grains, right? And use that to illuminate the interior spaces. So in this kind of setup, right, you realize that actually um, it's more to create a certain ambience, right? Rather than allowing you to say take out your laptop and do your work, or to do drafting, right? The nature of the space is different. Okay, the function of the space is different. So you have to establish that, and then we consider how the materials around is constructed around the space to elevate that quality. Okay, so once again, if we are using marble, right, and we're trying to illuminate it, okay, so natural daylight is one thing. What about artificial lighting? Is there a way to compose, to detail the LED lights, artificial lighting in such a way that the marble achieves a certain glow throughout the day? Okay, so this is possible as well, and in fact, it's very important because most of the spaces, not all the spaces, deep into the interior of the floor plan can have access to this level of natural daylight. Okay, so once again, you need to understand what goes into a lighting component, what is the detailing that's involved, right? And the technicalities before we can really detail something that works and is aesthetically pleasing, right? So zooming in a bit, this is interior design. So it becomes a bit more whimsical and very subjective in design, right? But in this kind of setup, similar to very Wes Anderson inspired kind of interior setup. How do we then detail? How do we then provide these lightings? Okay, so you notice that actually there's some focus because this is an eatery, and there's a bar counter behind. So how does a space connects? How are the space littered? How are the specific functions that's being littered? Right, all this has to be considered and curated, and there is a very controlled color palette as well, where there's a contrast of green with red and maroon, right? So where do we cast that light, so on and so forth. Okay, so all this actually lighting is a very important part of the entire kind of material components at your disposal to curate into a cohesive whole. Okay, so back to the content, right? I think two basic LOs for this sharing. So firstly, to understand what is a luminaire and what different types are there. Okay, so L1 is important because in the past few semesters, um, we realized that one of the things that usually falls short, right, is that when the student is very engrossed in developing the concepts and the floor plan, usually the renderings, how the space look like is left to the last bit, right? So at the very last minute when you're doing production and then you do a render, right, and you put your render onto the board, you realize that, oh, actually it's very evident visually that there is no the student haven't thought about the ceiling, what to do with the ceiling yet. Okay, so you need to know what kind of luminaires there are, the different types, what kind of functions they play, right? In order to think about this at the start when you are imagining the space, right? The quality of the space and what you are trying to curate. Okay, LO2 is to understand the type of emergency supply and the type of emergency luminaires and the supply system. So L2 is very important because last week we covered fire safety, right? Fire protection. So in the event of fire, actually most of the system will stop working. We will trip, right? And only the emergency lighting with access to the emergency backup power supply will be still functioning, right? This will ensure that the user of the space can evacuate in a safe and orderly manner, and then they know where exactly the escape path is. Okay, so to understand LO2 is very important as well for our work. Okay, so what is a luminaire? Basically, it's light fitting, an apparatus which controls the distribution of light given out by lamps, and it includes the lamp itself and the holder, okay, the control gears and the wiring, the housing, and reflectors, deflectors, so on and so forth. So actually these four main components, it's important to know them because you need to know how to fix them, right? How to assemble them with the rest of the fittings. And control gears and wirings, this is something that beginners usually leave out, or rather they miss, and it becomes an afterthought, right? So if you are looking in detail design, you need to know what you are designing for. For example, a strip of LED light, if you use it to light up a piece of carpentry, is very nice. But the question that you didn't think about is, oh, then where do we house the transformer, right? And where do we house the switch? Yeah, so those are actually part of the luminaire that we have to think about. Okay, so housing, reflectors, deflectors, those are important because if you run a quick search on DZine and stuff like that, or actually most of the interesting examples are in the libraries, in physical books, right? There's a lot of potential that we can design in the way that the reflectors and the deflectors plays around with the light. Okay, so this is just a possibility that designers can branch into too, lighting design. So installation methods of luminaires, you can do it recessed, right? Flush in, integrated into the ceiling or the walls. It can be surface mount, right? In this case, the electrical point is provided, and then you pick a nice light fitting and you mount it, and most of the fitting is exposed. Okay, so between the first and second, it depends on the overall architectural language that you're after. It can be pendant mounted, usually for like light fittings dangling over the dining table, sometimes over a workstation as well, right? Because remember that we were saying that actually you need to cater for different levels of lighting. So in a very specific task, right? Let's say in a library, and then this desk is for reading. You might want to provide general lighting, and in addition to that, we will dangle a pendant now down closer to the tabletop, right? So that allows the book that you're reading to be better illuminated. Okay, the last one is pole mounted. Usually is used in landscaping, right? So you have either the floor mounted and the pole mounted kind of lights that come together to illuminate the landscape. Okay, these are examples of the recessed mount. It can be above ceiling, the housing. Most of the housing is located above ceiling. You can locate it in walls. You can locate it in floors as well. Okay, so floors, many ways, many areas we can use it. It can be used in landscaping, right? Uplighters. It can be used to light the pathways. It can be used to light the staircase tread and risers, so on and so forth. Okay, but the main thing is that the finish level is flat, right? And then the housing sits behind. Okay, you can have it surface mounted. Okay, you can find it on ceiling surfaces or wall surfaces. These are where sometimes the shape of the light fitting, right, itself might be a consideration, because, for example, the ones that you see, right, is cylindrical, very specific material being used. So that might be something you want to play with also in the interior setup. Okay, so not all the time. Okay, I think for most of the time, if we, okay, this is subjective. Depending on the intent behind your design. Okay, things need not be recessed all the time. Sometimes if you are specifying very nice light fixtures, something that is designed, right, you might want to expose it and then to elevate, to showcase the design of the lamp itself, right? That's when you can go for surface mounted. And of course, this is relatively easier to replace. Okay, so that okay, the little red markings you see at the bottom, right? This was annotations left from a previous discussion. So it sketches, right, very briefly the because you notice the walls between the space between the common corridor and the interior spaces, there are openings. Okay, so in the design of a wall itself, that can become a source of light, right? So if the because relatively speaking, let's say the corridors don't need that much of lighting compared to the spaces within. Okay, so we can create openings where the general lighting of the space inside the room, right, actually deflects, is allowed to deflect outwards. And with that, actually it becomes quite obvious whether the space is being used or not, right? So it becomes a more lively kind of walkway, passageway. Okay, so some example of surface mounted light fixtures, right? These examples are wall surfaces. Okay, so sometimes you can have a series of components coming together. The throw of the light is also something that designers can play with, right? And you can specify accordingly. Okay, and in this slide itself, you notice, right, how many types of color, how many colors of light do you see? Right, here we are talking about luminaires, but you look at the effect of the light. You realize that, okay, on the left is a bit yellowish and orangey, right? Then on the right top, that is close to white, right? So at the right bottom, that is white, but there's a certain warmth, a certain orangey tinge to it, right? So generally in the industry, these are the kind of the three kinds of lights that we have at the moment, right? We have the daylight. Daylight, as the name suggests, is a kind of artificial lighting tone and temperature that mimics the sun, right? So it's very white, right? Which is what you see on the top right. Then you have a cool white, and then you have a warm white, right? So example of cool white is what you see at the right bottom, right? It is predominantly white, but there's a certain there's a certain color to that, right? So that is cool white, and on the left are examples of warm white. Okay, so if you are doing interior design, this is one of the first things you think about when you are designing for certain components or certain spaces. Like, what kind of effect am I after? Okay, pendant light, mounted light fittings suspended below ceiling. It can be direct and indirect lighting. Okay, so these two examples are our engineer friends' impression of pendant lights, what they think is nice, right? So if you go and to Dezeen, take a look. If you go shopping, right, you can find many other examples out there. Okay, it can be pole mounted. If you have it usually at around 1 meters height, bollard lights and footpaths, right, is used to illuminate the footpaths in the landscape. Okay, so that so when you're walking along the footpath, you know where it is, right? So the bollard position itself will guide you where is the path, and then the shine of the light, right, will light up the surroundings. Okay, so at approximately a 2+ meters to 3 meters level, you have the street lamps, right? This is for general lighting, so no specific function, but rather to light the space around generally. Okay, so at 7 to 10 meters level, that will be the street lighting. All right, the street lamps that usually illuminate the roads. Okay, so if you are dealing with pole mounted, I think for another kind of lighting, if you are talking about this can be surface mounted if you're looking at okay, in certain instance, for example, if you're designing for a very interesting structure in a landscape, right? Or if you're dealing with a conserved building, right? You might then want to incorporate like uplighters or surface mounted lighting, right? Because in that case, the object itself, the building itself, becomes an experience in the landscape. So it's not 100% landscape. Sometimes we have to bring in the buildings and the objects, right? Which then we have to consider how do we light them up. Okay, examples of direct, indirect lighting. Direct lighting, as the name suggests, within the light fixture itself, right? The light is cast on the area that is focusing on, right? Indirect lighting, for example, in this case, when you look at the cove lighting example, you notice that the LED light is projecting on a wall, on a ceiling surface, right? And then it doesn't project directly on the dining table or the stage. Okay, so in this kind of setup, there will be indirect lighting, usually used to create a certain ambience, and then there's direct lighting shining on the stage and the dining tables. So types of luminaires. Okay, this one we'll just run through. Just run through it very briefly. The different types there are, because now, in our context, right, in a few years' time, coming very soon, we will only be dealing with LED lights, right? We only be dealing with LED lights. It's just a matter of what grade of LED lights, right? And then there are a lot of innovations that are coming. They are coming into place. You will see a couple of them probably when you are doing your case studies. Very interesting. Yeah, but what we're going to run through here, most of it will be very dated. They are very dated, will be very dated, right? But it's good to know. So this, what you see on the screen, incandescence lamp, okay, where you are depending on, you have a bulb, right? Within the bulb itself, there's a certain gas, right? And then you run an electrical current through the filament for it to light up. Yeah. So when I was a kid, right, these are the kind of bulbs that I deal with, right? There's no LED. LED was like, wow, something else back then. Okay, but now it's only going to be LED in a few years' time. So okay, halogen lamps. Example of how it looks like. It functions with the same principle as the incandescence lamp, right? But it uses the halogen gas, right? So there's a very precise angle that we can focus this light. Okay, so it's usually used for flood lighting, sports lighting, for display. Like if you have giant billboards and you want to shine light on it, right? Usually you will go for halogen lamps. Okay, so if you are in a photography studio as well, if they need to shine light on the subject, halogen lamp will be used. Projector screens, motor car headlamps, for etc. Right? At the moment, still rely on halogen lamps. Okay, there's also gas discharge lamps, where it depends on the passage of electrical current through the vapor or gas. So it's more efficient than the electric heating method, right? Which the halogen lamp and the incandescence lamp functions based on heating. You are heating a filament for it to glow, and then with that glow, actually comes the light. Okay, whereas this is passing through a kind of vapor or a gas to illuminate from the visible radiation. All right, so in terms of energy, it's more efficient, because in the previous two method, a lot of the electrical energy that's being used actually gets transferred into heat, right? That dissipates. So the color of light in the gas discharge lamps produced depends on the type of gas, right, or metallic vapor that is contained within the discharge tube, and the pressure, right? So the third point, if you think about it, it offers a lot of opportunity in terms of lighting design. Okay, we also have gaseous discharge lamps, fluorescent gaseous discharge lamps, fluorescent lamps, compact fluorescent lamps, low pressure sodium lamps, and high intensity discharge lamps. Okay, example of fluorescent lamps. So the components is that you have the lamp itself, right? It's connected to the switch. You also need a capacitor, a starter, and a ballast. Okay, so I think today's context, very seldom. This is predominantly the kind of lamps that household use, say in the 80s, yeah, 80s and 90s. But nowadays, most of it is LED, right? So when you're dealing with fluorescent lamps, right, and if you need to replace it, you'll find that actually most of the time the lamp is still functioning. It is the starter and the starter, the ballast, and the capacitor that has fused or that has worn out that you need to replace. Right. So actually, back in those days, you can purchase the starter and the capacity separately from the shops, right, and do a replacement. So actually, similarly for LED lights as well. Sometimes the light, although it has a very long lifespan, but the transformer itself is the one that breaks down. Okay, so fluorescent light comes in many different possibilities, many different colors that's available. Okay, so a lot of design opportunities there. So the different types of fluorescent lights in the market, if you are designing for the light fixture, then we have to specify the type of lights, the lamps that we want, right? Is it T5, T12, T8, so on and so forth. Okay, all these will be included, right, in the specifications for the contractor to build, right? So of course the electrical engineer you work together with the electrical engineer to establish all this. We have the compact fluorescent lamps, right? Smaller, but the concept is the same, where the capacitor and the starter is all built into one, right? So you can see it. Sometimes it comes in a U shape, sometimes is a various cylinders, is a zigzag, so on and so forth, right? But the concept is still the same. So all these are available off the shelf, right, in supermarkets as well. So compact fluorescent lamps is measured, how it performs, right? Performance is measured in terms of efficacy, which basically means the light output, usually measured in lumens per watt of power consumption. Right, so the table itself, you can see the difference from incandescent lamp all the way to high pressure sodium lamp. The lifespan is very different, from 1,000 hours all the way to 20,000 hours, right? And the typical efficacy as well. So actually from that, right, you can kind of infer like why usually the households, they previously used incandescent lamp, and then they transited to fluorescent lamp because of the increase in efficacy and the increase in lifespan. Okay, and then the incandescent lamp has been slowly phased out in the past. And if you look at another thing to consider when you're talking about lifespan is also how frequently you have to replace. Like if you, for a living room light, it's very easy, right? Take a ladder, or maybe even a chair, and then you can replace it. But what happens if it's a street light? What if it's a roadside lamp, right? For you to go up and replace it takes so much work and resources, right? So in that kind of setup, actually the lifespan of a lamp is a very important consideration, and because it's at such high level, so the efficacy has to be at a higher level as well for more distributed and sufficient illuminance. Okay, low pressure sodium lamps. Okay, just be aware. If you're interested, you can go and find out more about those. Usually, last time in our context, is used for street lighting, used for security lighting and general area lighting. Okay, and you notice these two images, it looks very orangey, right? Yeah, it's very orangey. So it used to be used a lot in street lighting and for lighting the roads as well. But in today's context, if you observe around the roads at night, right, most of it is white. Yeah, because of the transition to LED. Okay, so low pressure sodium lamp once again has been phased out. gradually phase out to LED. Yeah, so but it's still being used in other countries. So it's always depending on where you are at which phase of development you are, right? It usually impacts the kind of fittings and what you see in the built-up area around you. Okay, so we have been there before. So at the moment we are transiting to LED. Okay, so I think in the past maybe 15 years, yeah, you can see marked changes. 15 to 20 years, you can see marked changes in the way that the roads have transited from an orangey kind of tinge to very white and very clear. Yeah, so sometimes I do wonder, right? This is about once again quality, the qualitative aspect of lighting the streets. Yeah, so when you look at this orangey light, right? When you compare orangey light to the white LED light we have nowadays, the white LED lights, of course, it looks cleaner, right? It looks safer. It's more brightly lit, right? But if you think further, there's a kind of quality that is lost in the process. It is like a trade-off, in fact, right? So just try to think about if you are walking along, say, one of the streets in like Paris, right? And they're still using street lighting that has a very warm tinge. Yeah, so sometimes you wonder whether that is whether that impacts the overall atmosphere of that space, you know. So and then with it actually comes it comes along with qualities like the romantic nature of the streetscape that we usually associate with Paris and certain parts of Europe. Yeah, so something to think about. Okay, so there's high intensity discharge lamps, right, where mercury vapor lamps, sodium vapor lamps, metal halide lamps, and there is high lumens output efficiency. It can be used indoors or outdoors, where the color criteria is not that critical, right? Which means that general factories, warehouse, industrial areas, exhibition areas will likely use this kind of metal halide lamps, right? Because of the high efficiency, because of the coverage, right? Because of the lifespan, right? It's usually at high level, but as the point goes, right? This is where the usage of the space doesn't really require very specific specification for the quality of the light. Yeah, so if you go to a restaurant, they're usually very specific about how the light brings out the food, right? So in those kind of setup, of course, you cannot use metal halide lamps, right? And metal halide lamps used for stadiums as well, right? So once again, very high level. It needs to shine and perform, right, across a very large area. Yeah, so these kind of lamps will be very suitable for it. Okay, so just now we're talking about Paris and the type of lighting. So we have an example of light fixtures is sodium flood lighting, usually used to illuminate the entire structure itself, right? So the entire structure itself becomes like a component of the urban view. Okay, so this kind of floodlights illuminates the entire component. Okay, so LED lamps is going to be our main source of artificial light. Okay, so this is how it works. If you're interested, you can read in detail. Pretty interesting, actually. So the advantages is that it's very energy efficient, right? It requires very low wattage and current. Okay, and the total power output is usually less than 150 milliwatts, so very energy efficient. It has a very fast response time, only about 10 nanoseconds, barely noticeable lah. So the moment you flick the switch, usually the light comes on. right? So not sure whether you all have used the incandescence kind of bulb before. When you flick it, right, the starter will activate, and then it will blink, 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 and come on. So it takes a few blink. Yep. So there's a delay between flicking the switch and then it coming on. So it does not need heating and warm up time. So no heat loss contributes to the energy efficiency. It's small in size and light in weight, right? Meaning is very easily incorporated into the interior design. It very easily incorporated into lighting, right? So it's very widely used in interior designs. Okay, so it's small but it's rugged in construction. It can withstand shock and vibrations, right? We are talking about the lamps itself, right? Not the transformer, lah. Okay, and the switches, those are usually more sensitive. And it has a lifespan of more than 20 years, apparently. The light fixture itself, um, this is on paper. Yeah, so this is on paper, but bearing in mind that LED lights is usually, let's see whether we have an image. Okay, don't have. Okay, LED lights is usually a series of very small lights coming together, right? For example, if you have a linear LED light, usually it's a series of dots, right? So although the entire fixture itself has a long lifespan, sometimes one or two of those dots will malfunction first, right? So that actually compromises the distribution of the uniformity of the light within that fixture itself. Okay, that is one thing, and the other thing is also what needs to be changed. Usually is the transformer and the switch. Okay, so yeah lah, but on paper LED has a very long lifespan. Okay, everything has its pros and cons. So these advantages is that you need a slight excess of voltage or currents. Even the slight excess of voltage or currents can damage the device. Okay, very sensitive, and it has a much wider bandwidth compared to the laser, and temperature depends on the radiant output power and wavelength. Okay, so over time, it might the quality, the color of the lighting might change slightly over time. Okay, so those are the type of luminaires that we have. The very general ones lah. Nowadays, there are very interesting ones in the market as well, which we will not cover here. Okay, next up, we'll talk about the term illuminance, which is basically how you measure the lighting level on of an object. Is measured in terms of lux. Okay, so it depends on the type of luminaires, the number of luminaires, the height of an installation, the height of the working plane, and the reflectance of the wall and ceiling surfaces. Okay, so these are the variables that affects the performance of illuminants. Okay, so once again, the Illuminating Engineering Society, in short, we call it IES. Okay, so IES, when you go and practice, you will come across this term. There is a recommendation for the illuminance based on the building, the function of the space, the type of the building, etc. Okay, so these are generally just to illustrate the difference recommendation for lux level. Okay, the list is very extensive. So for example, for concert halls, right, recommended illuminance is 100. Okay, so you try to imagine a concert hall. Marina Bay Sands is not a good example actually. So if you think about Esplanade, when you're in the theater space, when you're in the concert hall, the kind of feeling of that space, that will be 100 lux. Okay, similarly to say maybe a restaurant, right? Some of them might go 100, 150, so on and so forth. Okay, because it's more about creating the ambience. And for a concert hall, you want majority of the attention to be on the stage, right? So the stage itself will have a different lux requirement compared to the seating area, right? And then it's dimmable. Okay, so general office areas, right? It will be 500 generally, right? And if the office, it will branch. Sometimes it branch off in this guide specific functions like if it's for drawing, like a studio space, or it's an old kind of the traditional kind of architectural office where you still rely on drafting, physical drafting, right? That the recommended illuminance will be elevated, it will be 750. Okay, so you can also provide maybe two different levels, because if you provide 750 across the board, right, the room is very well lit, right, but there will be certain fatigue that comes along in that kind of setup, right? So we can lit the general office area in one lux level, right? A gentler lux level, maybe 300 and 400, and then for the general workstations, right, it might come with their individual lamps that brings up the illuminance level to 750 lah. Right, so there is many different levels that we can play around with. Okay, then for a factory assembly line, because it's precision, things have to be so precise there. The parts are so small. Sometimes you have to look under the microscope, right? In those kind of setup, we need 1,500 lux is recommended. Okay. So that was just an example of how do we measure lux level and how do we specify the type of lighting that you want in that space. Okay, so next up we'll go to LO2, which is about emergency lighting and the principles behind their provision. Okay, so emergency lighting is you'll be activated when the electrical system fails, or when there's interruption of power supply to a lighting circuit, right? So the first two can be generalized into during emergency lah, I would say, during emergency. And the purpose of having emergency lighting is purely functional, right? It allows the occupants to find the exits with ease and certainty. So in the photograph that you see, right, in this case, even though everything, all the power shuts down, the entire electrical supply to the building trips, right, the emergency light will come on because it's routed to an emergency power supply. And with that, right, it's just sufficient light for the user of the space to know where to go. Yeah, so just functional, and in a most simple way, in the simplest of way to point towards the exits. Okay, so there are three types. It can be maintained, it can be non-maintained, it can be sustained. So maintained meaning it's energized at all times for normal or emergency lighting, and it has a lower lighting level during emergency. Okay, so for example, we need not provide an independent light fixtures. Sometimes you can specify one of the light fixtures, usually near the exit, right, to be an emergency light. So you can turn it on and off and use it for daily use, right? But it's connected, it has a backup power supply connected to that. So during emergency, right, it will still come on, but operate at a lower lighting level. Okay, non-maintained means it only comes into operation when supply to normal lighting fails. Okay, so usually those type will be individual fixtures by itself because it needs a trigger, right? So once the normal power supply to the normal lighting fails, then the switch is triggered and then it comes on. Okay, sustained means that it has two or more lamps, of which one will operate during emergency. Okay, so emergency power sources, it can be the mains, failure, standby generators. So if you have a power main, you have a backup standby generator, right? Usually in its own compartment. Okay, then for the electrical cabling, you have to cable it all the way to that standby generator. Okay, it can also be powered from a battery pack with monitoring and test facilities, which has been monitored and tested regularly, right? So this shall provide at least 1 hour electrical supply to the emergency lights. Okay, so usually those standalone This is in the industry what we call Mickey Mouse light, because it's like two Mickey Mouse ears. So these are commonly used as a kind of emergency lighting solution. Okay, it comes with its own battery pack, right? Whereas although you can route the lights to the standby generators, right? Usually we use the standby generators for more important functions lah, like purging or the lift. Okay. So except for purpose group 1, right, which we try to recollect based on last sharing, purpose group 1 and 2 are residential. So purpose group 1 is small residential. Okay, so other than small residential typology, emergency lighting is required for corridors and lobbies with a minimum level of 0.5 lux, right, and a maximum spacing of luminaires. Okay, it shall be provided along occupied areas and locations, along paths that leads to corridors, lobbies, and exits in all occupied areas, where the direct distance from the point of entry of corridor, lobby, and exit to the furthest point in the area concerned exceeds 13 meters, right? So this is extracted from the fire code. So over a whole of such area, if no explicit path leading to corridor, lobbies, and exits, and rooms having direct distance of more than 13 meters and designed with a specific escape path. Okay, so once again, this is how they describe things in the fire code. And over time, you'll develop a way of translating this into diagrams, into something physical. Okay, so if you don't get it, it's too confusing now. It's okay. Just have a sense of how it works. Okay, and it might be easier if you take a pen and a paper. As you read, you try to sketch out what they mean. Then you'll be more easily understood. Okay, so yes, to be provided in rooms having provided at lift cars, fire command centers, generator rooms, basement, car parks, fire pump rooms, area of refuge within the same buildings, to illuminate fire alarm panels, call points, equipment, so on and so forth. Okay, so all these, that's why you have to understand the firefighting measures, right, that we have designed for in the building, right? And then next layer to that is that during emergency, how do we make sure the users know where to evacuate, and then the firefighters have sufficient light to carry out their work. Okay, so it's layer upon layer. You can't skip any of those. Okay, so exit lighting, exit sign shall be placed over the exit access door, serving as a means of escape. Okay, so in your classroom, just look up, right, there will be a green color illuminated exit sign above the door. And then when you're in the lift lobby, you'll find that same sign at the staircase. Okay, so once again, during emergency, just keep calm and look for those illuminated exit signs. Some of them is just an exit sign. Some of them is an exit sign with an arrow. Okay, so usually there are only two types. So you just look for it. If there's an arrow, just follow the direction of the arrow. Okay, so the architects will have checked it. The qualified person should have checked it. The registered inspector, which is third-party inspectors, would have checked it. And then sometimes SCDF will conduct additional layers of check. Okay, so many eyes checking in the design to make sure the building is safe. Okay, for example, as mentioned just now, directional signs. In this case, for example, if you're outside, if you're in the classroom, the first exit sign that you see will be for the door, right? So after you get out from the door, you look for the next exit sign. So if there is a right turn, as you see in the slides, right, there will be an exit sign with a direction arrow asking you to turn right, sorry. Yeah, so as the name suggests, is used when there's a change of direction, right? Sometimes it can tell you can either turn left or turn right. All right, so depending on the design, but usually we do not leave ambiguity, right? We want to be as definite as possible because during emergency, everybody is already in a panicky state of mind, right? We don't want them to overthink. Yeah, we just want them to follow the instructions and thereby exiting the building safely. Okay, exit sign is not required when one exit access door is provided. Yeah, so there are these kind of exemptions that are worked into it. Yeah, but it's always good to have. Yeah, the code always stipulates the bare minimum, right? As designers, we can design above and beyond, right? If you think it's beneficial during emergency. Okay, so this one you can read off. It's usually green lettering on white background or a white lettering on green background, right? But if you are using one type, the type that you have specified shall be consistent throughout the entire building, right? So that you won't have a situation whereby on one story it uses green lettering on the white background, and then you go to another story is white lettering on green background, right? It should be consistent throughout the entire building. Okay, so this is how it looks like. It's self-contained, right? And very obviously it points to where the exit is. Okay, so with that, I've come to the end of the sharing on lighting. It's a very brief sharing, so thank you for your attention.